In this video, we'll take a look at a few more sum and difference identities and how to simplify them. Here we want to think about simplifying a single trigonometric function or numerical value using the sum and difference identity. So let's start with problem 10. We have the tangent of pi over 2 plus x. Well, working with a single trigonometric function, usually it's a good idea to get in terms of sines and cosines. Tangents are a little bit tougher to work with when we want to simplify. So one expression we could rewrite this as is the sine of pi over 2 plus x, and then divide by the cosine of pi over 2 plus x. So we're working with really the sum form of the sine and the sum angle identity for the cosine as well. So if we look at the sum identities for both of those, we can consider them as the following. That will be first the sine. If I wanted to rewrite, and I'll do this in a different color, this identity in the numerator, the sine identity, we can rewrite as the sine of, we'll just call it angle A, cosine of B, and then plus cosine of A, sine of B. So that would be our identity for the sum sine A plus B. And then we'll want to divide by the sum of cosine function, or cosine angles. We'll do this in a different color as well. In the denominator, the general expression here for cosine A plus B, we can rewrite this as the cosine of A times the cosine of B, and then minus the sine of A and the sine of B. So this is the expression I want to fit, and my A and my B are known, pi over 2 and x. So let's take a look at putting these into our expression, seeing how they simplify. So the A angle is pi over 2. So we're going to write this as sine of pi over 2, and then cosine of x plus cosine of pi over 2, and then sine of x. Divide all this by the cosine pi over 2 cosine of x minus sine of pi over 2, and then the sine of x. So that's quite a few expressions there, but we definitely can simplify this result. So let's see where we can simplify this. Pi over 2 is equivalent to 90 degrees, so my sine and cosine at 90 have a special result, 0 and 1. So the sine of pi over 2 we know is going to be 1. So this gives me 1. The cosine of pi over 2 is 0, so this actually results as a 0 in that term. And then we have it again, cosine of pi over 2 again goes to 0, and the sine of pi over 2 is again 1 in the denominator here. So this expression simplifies quite a bit for us. We can write this as the cosine of x plus a 0 is going to be leaving nothing for us. And then this will all just go to 0. And then we have a 0 times a cosine x, also going to be 0, and the only term to survive is the minus sine of x. So what we have here, cosine over sine, would be the cotangent function, and this happens to be negative. So we'll have negative cotangent x as our final expression here. So both these denominators have a component that goes to 0, and then parts of those go to 1 times cosine x, and then negative 1 times sine x. So that's how we get our solution. And we'll be done with this problem 10. So let's take a look at number 11 as well. Number 11, we have a difference of sine functions to start. So sine x minus pi. So let's just recall our difference of sine functions. So if I had a function sine A minus B, this general expression we can write as the sine of A, the cosine of B, minus the cosine of A, and then minus, or the sine of B. And I know A and B in this expression happens to be x and pi. So this is my A minus my B. So let's go to work to simplify this. We've got the sine of A to start, so sine of x. And then cosine of B would be cosine of pi minus the cosine of x, and then the sine of pi. Pi is another special quadrantal angle for us, same as 180 degrees. So we know that the cosine of pi is just going to result in negative 1 minus cosine of x, and then the sine, that's the height at 180 degrees, that would be 0. And so when I finish this expression, this whole second term goes away as 0, and we're left with sine of x. So negative sine x here is going to be our final result. Again, all of this goes to 0. All right, and that would be problem number 11, using the difference of cosine angles. The last expression we'll take a look at is number 12. So number 12, we have two sum angles, the cosine and the sine. So let's take a look at what we need for those. We're using the same identities really as we were in problem 10. So that's another special thing. So the cosine is the same identity that we have in red in problem 10. So this cosine will continue. We'll just write this portion in red. So the cosine of pi over 3 plus x, so we'll call that the A and the B, and we'll just write these in general again. This would be the cosine of angle A, and I'll just write this in one step here. So cosine of angle A, the cosine of B, minus the sine of A, and the sine of B. So that's the sum of cosines identity right there. We want to add to this the sum of sine identity, which we have up in blue if you take a look at our equation there in problem number 10. So let's write this in blue as well. We'll just jot down that same identity for the sine function. Again, our A in this case is going to be the pi over 6, and x is going to be the b. So let's just rewrite this with different letters. It's the same in terms of our expression, but let's just call this c plus b, just to distinguish between those two, or c plus d. We'll do that, different letters for those ones. So for the sine here, we're going to have sine of the first angle, which is for us c, cosine of d, and then plus the cosine of the first, which is c, and then finally sine of the d angle. All right, now it's time to put in our angles into practice here. So our A angle, notice, is pi over 3. So we're going to do cosine pi over 3. Then we'll have cosine of x minus the sine of A, sine of pi over 3. Sine of B is sine of x, plus the C angle is pi over 6, so we're going to do sine of pi over 6, cosine of the D angle, which is still x, plus cosine of the C angle, pi over 6, and then sine of D, or sine of x, which is that last angle. Okay. So let's see where we can evaluate this expression. We have some x's left, so we know we're going to get some function of x when we're done. So let's continue with this. Try to fill in the details. So cosine of pi over 3, starting over here, that's cosine of 60. We know that to be 1/2. So we have 1/2 cosine x minus sine of pi over 3 is going to be square root 3 over 2 times the sine of x, plus the sine of pi over 6, that's going to be sine of 30 degrees, which would be a 1/2. And then we'll still have cosine x. And then plus cosine of pi over 6, that's going to be our root 3 over 2 sine of x. All right, we'll notice here that a few items will cancel and we'll be able to add some like terms. So we have our sines. Those are exactly the same other than that minus sign, so these will cancel out to 0. And then 1/2 cosine plus 1/2 cosine, we know that that's going to simplify just down to 1 cosine. So our single result here is going to be cosine x. And we've completed this monster of a problem. So this problem 12 is just done by adding two identities together, the cosine sum and the sine sum together. So this would be our result, cosine of x. Look forward to seeing you. Actually, we'll do one more problem here. I know this is a long video, but we'll finish this up. The other items for the identities are the cofunctions, and we'll just finish this up real quick. The cofunctions identities. If we recall the cofunctions identity from the top of our page, remember that the sine and the cosine functions are cofunctions together, or the cotangent and the tangent are cofunctions, and the cosecant and the secant functions are cotangent, or cofunctions, excuse me. So when I consider the cofunctions, one example we gave from previous video was that the sine of 60 is the same as the cosine of 30. So if we said x is equal to 30 degrees, that gives us this identity right here. Both of those are square root 3 over 2. So we can make the expressions in our examples the same as well. So let's take a look at how we would identify the cofunctions in these last two examples. So these statements, secant of 17 and cosecant of blank, remember that the secant and the cosecant are cofunctions. So we can write an expression that says, for instance, that the secant of x is equal to the cosecant of 90 minus x, regardless of what that x value is. If it's a angle in degrees, we can measure that as our cofunction identity. So if x is equal to 17, we know that 90 minus 17 is going to give us 73. That would be right, 73. So secant of 17 degrees is the same as cosecant of 73 degrees. Again, based on that identity. The tangent function, if I wanted to find a cofunction to that, let's recall an identity for that. If I had the tangent of some value x, this is going to be equal to the cotangent of pi over 2 minus x, using the radian version of our cofunction identity. So here my x value is pi over 6, so we can work with this. This will be the same as cotangent pi over halves minus pi over 6. So we just have to work out this angle. Cotangent pi over 2 is the same as 3 pi over 6. And when we express this, 3 pi over 6 and pi over 6 will give me 2 pi over 6, or cotangent of pi over 3, pi thirds. So this identity will be finished off with the same as cotangent of pi over 3. So that's a little look at those cofunctions. Thanks for sticking around for the full video here. And this completes the section 10B.